These are the challenge questions which you find in competitions like SAT, AMC, or Olympiad. The top 20% questions. Now you must be wondering, why am I just doing one by one in each video? The idea here is I want you to solve them, right? And then apply the strategies. Once you've done so, look into my solutions in the next video. You get the idea. Okay. So in the earlier two videos, we actually solved these questions related to Ferris wheel and one related to the angle a line makes. Perfect. Now let's focus on the windmill question. It says, a windmill has its center 6 meters above the ground and blades 2 meter length. A point P at the tip of the blade makes a complete rotation in 12 seconds. At what time is P exactly 7 meters above the ground? Okay, so let's sketch the diagram. So we say that, let's say this is the windmill with blades which are 2 meter in length. And it's given that this windmill has center 6 meters above the ground, right? So let's say 6 meters above the ground. So let's say that is the. So that length is 6, okay? And we know this is 2 here, blade length, right? So this becomes 4. Now, we are really interested in finding out when will this point P, which is right here on top, a point P at the top of the blade makes to complete, okay, it takes a point P at the top of the blade makes complete rotation in 12 seconds. So one rotation or revolution in 12 seconds, right, one full. That basically means 360 degrees in 12 seconds, right? That is what revolution means. Full angle, 360 degrees. The question is, at what time is P exactly 7 meters above the ground? So 7 meters above the ground will be like 6 is the center. This is 8, right? This is 8, correct? 7 will be midway, right? So that is 7 meters. So we want to find the time which it takes to come to this particular position. Well, it could be 2 different times. Do you see that? Could be 2 different times. Let us say it is revolving clockwise. So if it is counterclockwise is considered positive, right? So we need to practically figure out how much angle does it make? This angle, right? How can you find this? So in earlier examples, as you know, we are looking into a situation where we know that the radius is 2, right? So this side is 2. However, 7 means 6 plus 1. So we have a right angle triangle where one side is 1 and the hypotenuse is 2. So if you have that situation, what are you reminded of? We have a right angle triangle in which one side is 1, hypotenuse is 2, right? Clearly, in right angle, the other will be square root 3, and this is 60 degrees, right? You get the idea. So we know that this angle now is 60 degrees from the special triangle, which is 30, 60, 90 degrees triangle. Makes sense? Since we know 60 degrees, we basically want to find how much time it takes to go through 60 degrees of rotation. So 360 degrees in 12 seconds, right? 1 will be in 12 divided by 360, and 60 degrees will be, just multiply this by 60. Great. And simplify. So 60 goes 6 times and this goes 2 times. And therefore, answer is 2. But what you notice here is that 2 is not a choice. You see that? 2 is not a choice. So now, how are you going to solve it? So that's the tricky part, right? So clearly, as I said in the beginning, once it does this rotation, it is at 7 feet here, but while completing the rotation, it is also at 7 sometime later. Do you see that? And one full rotation is 12 seconds, and this is 2 seconds before that. Do you see that? So it is 12 minus 2, which is 10 seconds. So it takes 10 seconds to actually go from here to there. You get the idea. And therefore, 10 is the right answer. So it reaches again the height of 7 feet, and it takes altogether not just 60 degrees, but 60 degrees less than 360, right? So it goes through all that, 300 degrees. You get an idea, right? 300 degrees it goes through. And it takes 10 seconds to be there. So I hope with this you have understood how do we solve questions which are based on rotation, right? Angles are involved, like in Ferris wheel, angles were involved, and a height is involved, right? So the concept is of gradient, the angle which it makes or rotates through. All of these things come together when we solve such questions. Second, also remember that there are two positions as in this case. So look for the alternate answer if what you calculate in the first place is not there. You get the idea. So that's the tricky part. So especially if you take care of such things, you could actually answer the last question of the competition successfully. So that is all about our classes, right? So we try to teach you the concept, how it should be applied, and where it can be applied. As soon as you see a question, look for the solution since we have done many of those kinds. Perfect. If you follow these strategies, you should be very successful in any competition to come. You can always join my classes and learn more. The Road to Success with Anil Kumar. Thanks for your time and all the best.